is about solving these and or statements. So for and statements, you're going to do this one thing, which is essentially to highlight the expression in the middle of the symbol. You set up an equation with each side of each symbol. Last, you solve for x. For or statements, you solve the first expression, then you solve the second expression. And these statements are ready to solve. So the directions are to solve the statements, write whether it is an and or statement, graph the statement, and write the interval notation. So it appears to be an and statement. So I'm going to make sure. So the first thing you do, highlight the expression in the middle of the symbols. So I'm highlighting this expression, right? Then you set up an equation with each side of each symbol. So what does that mean? You're going to set up an equation using this information here. So we're going to use this whole space right here. Use the whole space. So on the left-hand side, in that left-hand box, I'm going to write the statement. So -2 is less than or equal to this highlighted portion. This is only for and statements. 3x minus 8. Okay? Now, on the right, I'm going to write my second statement. 3x minus 8 is less than 10. So right now, I know that this is an and statement. I'm going to make a big deal about it and write and over here. I want you to do the same. Okay? Now we're going to solve for the variable. So the first part, for the first side, we're going to add 8 to both sides. Add 8 to both sides. I'm going to combine those like terms on both sides of that symbol, right? And -2 plus 8 is 6. Less than or equal to comes down. 3x's comes down. Now my goal here is to solve for the x. So I divide both sides by 3. And x is greater than or equal to 2. Keep in mind, this is an and statement, so I'm going to be creating this graph that looks that's going to have 2 endpoints. So for the next portion, I'm going to add 8 to both sides, right? Add 8 to both sides is this inequality. Draw my line underneath. I get 3x less than 18. Divide both sides by 3. And x is less than 6. So I'm going to come down to my graph and write my numbers. 2 and 6 is over here somewhere. And let's look at the symbols here. So for 2 less than or equal to, it's a filled-in circle. At 6, it's not equal to, so it's an open hole. And then I just join the 2 endpoints together. And I'm going to write the interval notation. So I have a hard bracket where 2 is at because it's filled in. 2, comma 6, and a parentheses. Now the next one is, I'm going to type it. And the next one is, it is a or statement. This is an or statement. So I'm just going to come over here and type or, okay. This is an or statement. And so all I have to do is separate these two. I don't have to do a lot of work like I did before. So 3x plus 1 less than 4. Right? And over here, I have I have the second portion, which is 2x minus 5, is greater than 7. Okay? So I can go through and do the work here. So minus 1 on both sides here, so I can get the x by itself. I get 3x comes down, 1 minus 1 goes away, symbol comes down, 3 comes down, divide both sides by 3, and x is less than 1. Okay? Over here, add 5 to both sides. Add 5 to both sides. And I get 2x comes down, this goes away, greater than 12. I want to solve for x, so I divide both sides by 2. Divide both sides by 2. And what happens is the 2's cancel, x is greater than 6. Now, here's my numbers, 1 and 6. So nothing's filled in, so it's an open circle at 1 and 6, right? But all the numbers less than 1 go towards the left. All the numbers greater than 6 are towards the right of 6. And there's my graph. Interval notation indicates I'm coming from negative infinity. I stop at 1, so parentheses, negative infinity, comma, stop at 1, close parentheses, put a U for a union, then comma, 6, and I'm going towards positive infinity. Okay? So that's essentially how you prepare and or statements. The next section, you're going to have to be careful. Remember, if you divide or multiply by a negative number, you have to flip the symbols. And if we're flipping symbols, we're probably changing whether or not it's an and statement or an or statement. So let's be careful. All right. So I'm going to highlight what's in between. I start off with an and statement. I'm also going to put a 1 in front of this x here. Put a 1 there. All right, so I'm going to rewrite that. I have negative 2 is less than negative 1x minus 2 on one side. And then on the other side, I have just taking that middle section, negative 1x minus 2 is less than 1. Okay? I'm going to make this a little bit smaller and push this over a little bit. All right. Now, let's do some work here. So, all right. So we're going to add 2 to both sides. So add 2 plus 2 to both sides of that equal side. Okay. And I get 0 coming down is less than negative 1x. And then this part goes away. That part goes away. This goes away. Now, if I divide by a negative number on both sides, if I divide by a number on both sides, x does not exist. It does not exist. This is a problem. It does not exist. I can't actually take that back. It's when you divide a number by 0. Sorry. So here, I divided by a negative number, so I'm going to flip the symbol, and it becomes 0 is greater than x. I flip the symbol. Make sure you flip the symbol. All right, for the next one, I'm going to add 2 to both sides, add 2 to both sides of the inequality symbol. So hope I didn't lose you. -1 comes down, this goes away, symbol comes down, 3 comes down, -1x, excuse me, it comes down. When I divide by -1 on both sides, that means the symbol flips. And we're going to see what kind of graph we create. We get x is greater than -3. So I have two numbers. The smaller number always goes first, so -3 goes on the right, and 0 goes on, sorry, -3 goes on the left, and 0 goes on the right. So both of these are open circles. They're open circles here, right? And so it says 0 is greater than all x values. 0 is greater than. That means 0 is greater than all these numbers here, right? It's going to be towards the left. So the negative does a certain type of thing. This negative that's attached to this x, when it causes the symbol to flip, does the opposite of what's there sometimes. But let's just check and make sure that we're on the same page here. Next one says x is greater than -3. So all the values greater than would be to the right. So here, this is an and statement. So we kind of work backwards a little bit. I thought it was going to create a statement that was different than what was there, but it's an and statement. And what it looks like, interval notation wise, it's going to have parentheses, -3, comma, 0, parentheses. And that's it. That's all she wrote. For the next one, I'm not going to look at that part. All right, we're going to set ourselves up for success here and write out these statements. So type them out here. I have -3 less than x plus 2. And then I have x plus 2 less than 9. Right? Make it a little bit smaller there. And then we're going to come over here and subtract that 2 on both sides to get that x by itself, right? Subtract 2 on both sides, and let me underline that so you should as well, right? Okay, and I get -1 is less than x. So there's my first part. This is an and statement. This is an and statement. It's an and statement. All right, and we're gonna prove it. So here I'm getting the x by itself, so I subtract 2 on both sides of this inequality. I get x is less than 7. So there's my two numbers. So I have -1 and I have 7 somewhere over here. The circles are not filled in, they're open circles, and all the numbers that are greater than -1 are to the left, and all the numbers that are less than 7 are to the, sorry, all the numbers that are greater than -1 are to the right, and all the numbers less than 7 are to the left. So this is an and statement. Looks like this in interval notation, -1 parentheses, comma 7, and close the parentheses. Okay. The next one is an and statement as well. This is an and statement. And when I set this up, I have -8 is less than 2x on one side, and then I have 2x. Remember, I used that portion in the middle twice, is less than or equal to 12. Divide both sides by 2 on the left, and I get x is less than negative 4. We are not dividing by a negative number. That 2 is not negative. Okay, and then over here, divide by 2 on both sides. And x is less than or equal to 6. Okay, so relatively easy. This is an and statement, so we're going to have these two numbers. Negative 4 is to the left, 6 is to the right. It's open circle at negative 4. It's a closed circle at 6. So make sure the circle's closed. And then we just draw our and statement with the line connected to endpoints. If I was going to do interval notation, it's not filled at negative 4, so I have a parentheses, comma, 6, close bracket, right? So that's pretty much wraps up a number of and statements. The next section is all about or statements here. So we're going to have those graphs that create opposite rays. So if I write this out, I have negative 2x plus 1. It's just two separate statements. It's already pretty much set up for you. Greater than or equal to 5, and then negative 3x less than or equal to 9. And then I'm subtracting 1 on both sides here. And I get negative 2x, that's a negative, is greater than 4. Now I am going to be dividing by a negative number, so I'm going to have to flip that symbol, and what I end up with, I'm just going to type it out here so it's easier to read and see. Negative, so x is, we flips over, less than negative 2. That's my left-hand side. On the right, I'm dividing by a negative number, so we're going to have to be careful here. Dividing by a negative number, and read the statements and graph each individual statement. And x, this becomes x is greater than, it flips over because of that negative 3 being divided, negative 3. Alright, so which number comes first? Negative 3 comes first, and then negative 2. So at negative 3, it's filled in. At 2, it's an open circle. Okay, so x is less than negative 2, so it's going towards the left here. And x is greater than or equal to negative 3, so it's going towards the right. And it started off with an and statement, or statement, but because of these negatives, these two negatives, we actually have scratch, 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 scratch. You actually have an and statement. So, correction. This is an and statement. Alright? That means my interval notation is negative 3, hard bracket because of the filled in circle, comma, negative 2. And we could even write it, the set notation, as negative 3 is less than or equal to x is less than negative 2. Okay? For 19, for page 19, these two problems you should do on your own, and then do the lesson 3 homework. Okay? Just make sure that you're indicating whether or not there's an and statement or an or statement. Here we go. And statement or statement. So do this on your own. Think about it. I'll give you a second to do it. And if you really need to, you go ahead and look at the last video to get page 19. Actually, I won't do another video. That's too much for you. I know it is. So I'll tell you what, I'll just do it with you. So let's highlight what's in between. It's probably going to be an and statement, but you can't never tell. You can never really tell. So let's just worry about that last. So negative 3 is less than or equal to 1 minus 2x on this side. Then 1 minus 2x, there's a negative there, so we got to be careful. It's less than 5, right? Okay. Now, so I'm going to combine like terms, subtract 1 on both sides of that symbol. Draw my line underneath, I get negative 4. Negative 4 is less than or equal to. This goes away. Negative 2x. Okay? Then I divide both sides by negative 2. And x is greater than or equal to, oh, I did something wrong. So you have to flip that symbol because you're dividing by a negative number. Flip the symbol so it becomes like that, and a positive 2. On the other side, I'm going to subtract 1 from both sides. I get this going away. I get negative 2x is less than positive 4. Okay, so divide both sides by negative 2. And remember, doing that flips the symbol. And I get x is greater than negative 2. Okay, so let's see what kind of statement we create here. So let's put our smallest number first. So negative 2 goes over here. Positive 2 goes over here somewhere. And we're going to have an open circle here. So x is greater than negative 2, so it's going towards the right of negative 2. On the other side, over here at 2, it's equal to, and 2 is greater than all these x values, so it's going towards the left. So this is an and statement. This is actually an and statement. And when we do our interval notation, we get negative 2, parentheses, negative 2, comma, 2, hard bracket for the filled in portion. And this is an and statement. I do believe this is the last one before your homework. So this is an or statement. So I have negative 5x. So I just split them up. No big deal here to do this portion of the or statements. Just split them up. So I'm going to do this first one over here first. So I divide by negative 5 on both sides because that negative 5 is a coefficient of x, and flips a symbol. Because of that, x is less than or equal to negative 3. Now on the right hand side, I'm just going to type that out. I have 2x plus 3 is less than 4. Okay, and I'm going to subtract 3 on both sides of that symbol, right? And I get 2x is less than 1. 4 minus 3 is 1. And what happens to those 3's? They just go away. Then I divide both sides by 2, and I get x is less than 0.5. So here, the symbol didn't flip, but the other one, symbol did. So let's go ahead and then look at this. So I have 5 over here, 0.5, 0.5, 0.5 right here, 0.5. Then keep going, and I have negative 3. So let's graph this one first. So I have it's equal to negative 3, so I fill it in, and all the values less than negative 3 go in this direction. This is one of those instances where you have overlap, and it's a special case, and we'll see what this means later on if we ever get to absolute values. So basically what happens is overlap occurs. So here it's not filled in because at 0.5, it's only less than. So there's overlap, and the graph actually looks like this. So -3 doesn't even matter. It doesn't even matter. And my graph, my interval notation is negative infinity all the way over to 0.5. And we're going to use parentheses. Special case, guys. Negative infinity, comma, 0.5. This is not an OR graph. This is not an OR graph. So we're going to write neither. Neither. There are no opposite rays. Neither. It's neither and, it's neither or. And I think that's a good way to close this section. It probably leaves you skeptical a little bit, like how do we do that? Go back and watch it. But I promise you this is a good way to close out this section of the notes. So next time we'll be doing lesson 3, and it's linear inequalities. Do your homework tonight. Make sure you're writing whether it's an and or statement. Make sure you're showing your work, graphing the inequality, and also doing interval notations. So you have about 2 pages, 3 pages of that, and next class would be this lesson here. It's lesson 3, not lesson 4. You guys have a good day. Hopefully I'll be back and not sick, and see you soon.